Welcome to lecture number 39. In this lecture we will solve a problem using loop analysis. In the next lecture we will solve the same problem using Thevenin's theorem. In this lecture was prepared on the request of a student, and she wants me to solve this question using two different techniques, and the answer should be the same, of course. This is the circuit and we are supposed to solve it for V out, this voltage that is across this 2 ohm resistor, using loop analysis. Right. In this circuit, if this is assumed to be loop number 1, this cannot be assumed as loop number 2 because this current source is common between the two loops, and we cannot have two such loops where there is a current source right in between the two loops. Therefore, we'll assume this as a loop, and for current I2 or the second loop, we will assume this longer path by bypassing this 2 at an angle of 90 amperes current source. This is very important, and the technique is called the super mesh technique, and you can find my older videos of basic electrical engineering course regarding mesh analysis for DC circuits. Right. For this first loop, we'll assume this I1 is definitely minus 2 at an angle of 90 amperes. Why minus 2 at an angle of 90 amperes? Why not anything else, and why have we not written an equation for this? In my DC analysis lectures, I have mentioned that if we have a current source in a loop, we don't write equation for that loop. Rather, we write the magnitude of that AC of that current equal to the magnitude of the current source by writing either with a positive or a negative sign. We write it positive if the direction of our assumed current is the same as the direction of the current source, but if they are opposite, we'll write a negative sign. So in this circuit we see they are opposite to each other, therefore we write a negative sign here. For this second loop, loop number 2, we'll write an equation. Let's start from here. Our assumed I2 current enters from the negative side of this 24 volt source, is a voltage rise, and we'll write it negative, plus through this 2 ohm resistor we have two currents, I1 and I2 flowing, so 2I1 plus 2I2. Through this next in the path is this minus J2 ohms capacitive reactance. So the current through it is minus 2, therefore write minus J2 I2, and the current flowing through this 2 ohm load resistor is 2 ohm, is the same as I2, and we'll write 2 I2. Simplifying this will lead us to this point where we have 2 I1 plus J4 minus Ji2 is equal to 24, or we can take 2 as a common from the left hand side and as well as from the right hand side. So this becomes I1 plus 2 minus J1 I2 is equal to 12, and then we have to put the value of I1. We'll put the value of I1 from here right here. So plug this value in here, minus 2 at an angle of 90, and plus 2 minus J1 I2, the same thing, is equal to 12. And then we can compute this I2. The numerator as well as the denominator are in rectangular form. We can convert them using polar form using a calculator, and then we have this I2. And finally we have to compute voltage across this 2 ohm resistor, which is 2 times the current flowing through it. So V out is 2 times I2. So we reach to a value 10.8 at an angle of 36 volt. In the next lecture, we will solve the same problem using Thevenin's theorem and we'll try to reach to the same answer. Thank you.